Hey everyone, and welcome to The Foundry by Forge College. I am absolutely thrilled you're joining us. Today's explainer is all about network configuration fundamentals. You can kind of think of this as the master blueprint for building a really highly functional digital city on the Solana blockchain. We're going to take some pretty complex infrastructure concepts and lay them out structurally and visually. If you've ever felt like network configuration is just this chaotic, endless list of command line flags and text files, well, you are definitely in the right place. We are going to bring some much-needed order to that chaos right now. So, to kick things off, we really need to answer one fundamental question. How exactly do we bridge intent and behavior? If you caught our previous lesson, the network selection checklist and considerations, you'll remember we made some big strategic choices. We looked at mainnet versus devnet, expected workloads, failure modes, the whole shebang. But here's the thing. Selecting your cluster is really just drawing the map. Configuration, that's building the actual bridge to your runtime behavior. It's how you enforce your intent so the network actually does what you need it to do when the pressure is on. Okay, let's dive right into this. Here is our architectural schematic for today's explainer. We're covering 6 main areas. First, how intent meets network behavior. Second, the core network configuration elements. Third, we'll unpack the ecosystem mental model. Fourth, we'll look at the classic trade-off of openness versus strict protection. Fifth, we'll walk through 6 steps to deployment. And finally, we'll wrap up with how to measure and iterate.
All right, part 1. Intent meets network behavior, or basically translating your high-level goals into low-level parameters.
Every deployment starts with a dream, right? Maybe you want ultra-low latency execution, or maybe you just need perfectly reproducible test runs in a continuous integration pipeline. But unfortunately, the network doesn't really understand dreams. It only understands parameters. So your job is to translate the intent of, say, a fast network into the reality of specific host selections, retry limits, and listen addresses. Now, the most visible surface area of this translation is the RPC endpoint. By definition, an RPC endpoint is a URL, or a set of URLs, that program clients and deployment scripts use to reach a cluster's JSON RPC interface. I actually like to think of the RPC endpoint as the main gate to our newly drafted digital city. Because think about it. If you don't know the address of the gate, you literally can't get in. If the gate is too small, traffic backs up. And if the gate is flat out broken, your entire application effectively drops off the map, even if the city inside is running flawlessly.
Moving right along to part 2, core network configuration elements. These are the nuts and bolts.
We're talking about the tangible levers, the dials, and the components that we have to actively tune and monitor to ensure absolute reliability across our Solana deployments. Now, what's really fascinating here is how these core variables break down operationally. Take client timeouts and retries, for example. The operational effect is simply how quickly a client gives up on a request, but the recommended use case? Totally depends. You actually want short, brutal timeouts for your continuous integration tests so that errors fail fast and loud. But flip that around for user-facing services, you want moderate timeouts with really generous retries to mask transient network hiccups from your users. It's the exact same configuration parameter, but completely inverted depending on your intent. And of course, you also have things like ledger paths for local storage and RPC permissioning for limiting API access.
Now, within those core elements, one of the absolutely most critical is your validator identity. This is a key path that securely associates consensus messages with your specific node's identity. So if the RPC endpoint is the gate to the city, your validator identity is your official cryptographic digital passport. It's what proves to the rest of the network that your node actually has the authority to participate, vote, and sign messages. You absolutely must protect this key path fiercely with secure storage.
So, how do we actually apply these settings in practice? Well, we generally use 2 methods: configuration files and environment variables. Think of configuration files as being etched in stone. They are canonical, they're version-controlled, and they establish the foundational rules of your node. And crucially, they should never contain secrets. Environment variables, on the other hand, are like bright little sticky notes placed right over the stone. They are ephemeral overrides, which makes them perfect for CI pipelines. You keep your ledger paths etched in the file, sure, but you use a sticky note to quickly swap out an RPC URL for a repeatable test workflow.
Let's step back for part 3, the ecosystem mental model: producers, consumers, and transport.
It's time to zoom out a bit. This conceptual framework is actually one we frequently explore in our Forge College learning programs because it elegantly simplifies incredibly complex architectures.
See, when you adjust one single configuration setting, it never happens in a vacuum. You are altering an entire living ecosystem. To break this down, we look at the ecosystem in three parts. You have producers, like your validators and clients, that generate state changes. You have consumers, like indexers and wallets, that read those state changes. And you have the transport layer, the RPC and gossip networks, moving all those messages around. So what happens if you, say, increase your validator snapshot frequency? Well, your node recovers faster, which is great for the producer. But that increases disk I/O, which slows down the indexer reading from that exact same disk, which is terrible for the consumer. This model helps you predict those cascading effects before they take down your staging environment.
Which brings us to part 4, openness versus strict protection, the ultimate security trade-off.
Understanding that ecosystem is totally crucial when making your security trade-offs. Every single network architect has to decide exactly how accessible their nodes, their RPC endpoints, and their transport layers should be to the chaotic outside world. It really comes down to choosing between a free-for-all internet buffet and a strictly guarded VIP club. Openness gives you incredibly easy developer access and fast, frictionless testing. The downside, you've got a massive attack surface where noisy consumers can just exhaust your resources. Strict protection, on the other hand, uses API tokens and IP allow lists. It's highly secure and fiercely protects your transport capacity, but it forces your consumers to navigate complex authentication routing just to get a tiny sip of data. It is a very delicate, deliberate balance between convenience and risk.
All right, part 5, 6 steps to deployment. Let's look at a practical configuration workflow. We've covered the components, the ecosystem, the security trade-offs. Now let's put it all together into a practical workflow. This is the exact sequence you should follow to prepare your Solana deployment reliably, every single time. Step 1. Define your goals and constraints in a manifest. Like, what is an acceptable latency? Write it down. Step 2. Establish that base configuration file we talked about, etched in stone in version control. Step 3. Apply those environment variable sticky notes for overrides. Step 4. Set your permissioning. Decide if you're the open buffet or the VIP club. Step 5. Run a test and measure your baseline validation. And finally, Step 6. Iterate and document any changes. I cannot stress this enough. Following this exact sequence is literally the difference between a smooth launch and frantic, hair-on-fire troubleshooting at 2 a.m. And that leads us nicely into part 6, measure, iterate, and wrap up. Setting that all-important baseline. So you've configured everything beautifully, but as the old engineering adage goes, you absolutely cannot improve what you do not track. You must establish a baseline. There are a few crucial metrics you need to be monitoring here. First, latency percentiles for your JSON RPC calls. Then, the actual transactions per second, or TPS, that your clients are observing. The time to finality for your transactions, and your node's snapshot frequency and write times. Think of these metrics as your early warning system. If you tweak a configuration file and suddenly your time to finality spikes out of nowhere, boom, you immediately know your change caused a regression. So you iterate, you document, and you fix it. To summarize everything we've looked at today, I want to leave you with this core thought. Configuration turns your environment choice into predictable behavior. Selecting mainnet or devnet, that's your strategic decision. But configuring the endpoints, the timeouts, the permissions, the overrides, that is how you operationalize that strategy. That's how you actually take control. Which brings us to the end of our blueprint. But it definitely leaves us with one final provocative question. Will your newly configured DevNet actually survive the stress of mainnet-like conditions? Well, that is exactly what we're going to tackle in our next lesson, where we apply these fundamentals at serious scale. Thank you so much for joining me today. To dive deeper into this subject and to explore a whole wealth of other fascinating Web3 topics, I highly encourage you to check out our platform at forge.college. Keep exploring, keep building, and I will see you in the next explainer.